Hey everyone, I'm Kostil, and today I'll be going through some subnetting for you guys. So just some practice for the subnetting. Many people find this difficult, but if you get the right practice, I honestly feel it's not that difficult. And I'll give you a few tips and tricks that I use throughout subnetting, and hopefully this helps every one of you. So I'll be dividing the videos into 2 to 3 different videos. So we have one easy and one hard subnetting practice for each type of question that could come potentially in an exam. And so I have 2 videos for basic subnetting, and then I'll have one on VLSM as well. So yeah, let's get started without any further ado. So the first question, it's really simple. They've given us an original prefix, which is the default subnet mask, and they've given us a new prefix. So this is what we have to convert our original subnet mask into. So the first thing it's asking us is to get the new mask in decimal. So currently the original subnet mask is /24, which means that the first 3 octets have all ones, and then the last octet is obviously 0. So the new subnet mask in binary we'll have 8 ones again for the first octet, 8 ones again for the second octet, 8 ones again for the third octet. And in the fourth one, since we're taking 4 more additional bits from the original mask, so the first 4 digits will be ones, and then they'll be followed by zeros. So 4 ones and 4 zeros. So this is our new subnet mask in binary. Now to convert this into decimal, since we know all these are already 255s, so we can just add that in, and we only need to calculate the last one. So I have another worksheet in here that we can use for calculating. So our first 4 bits here are ones followed by 0. So that means that we'll have 1 for 128. So we always start when converting decimal to binary, or binary to decimal rather. I made a mistake here. We always start with the highest number. So we have the 2 to the power table, which is, it starts from 2 to the power 0, goes up to 2 to the power 7. From 1 to 128, your numbers are basically just doubling every time till they reach to 128. So the first, and we start when converting, we always start with 128, and we go down. So if our number here, we need to find this number here. So the first 4 digits here are ones, and then followed by all zeros. So now we have 4 ones here, which means we'll add these 4 digits. So 128 plus 64 plus 32 plus 16, that is 240. And then since these are zeros, we don't do anything, we don't add anything. So 240 is the number. Yeah, 240. So we can fill in our mask here, which is 255.255.255.240. Now the number of hosts. A simple formula or equation to find the number of hosts is you take 2 to the power of the number of bits left, so the ones that are zeros, minus 2, because we minus 2 because the first and the last addresses will be one for the network address and one for the broadcast address. The last one's the broadcast and the first one's the network address. So the number of hosts will be 2 to the power 4 because we have 4 zeros left here, which is 16, minus 2, 14. So the number of hosts here will be 14. The number of subnets will be 2 to the power of the number of bits taken. So we've taken 4 bits here from 24 going up to 28. So 2 to the power 4 again, but this time we're not subtracting anything because we're just making subnets. So 16. Now the number of subnet bits here will be 4 because again, we started with 24, we added 4 more bits to the subnet. So the number of subnet bits will always be the new prefix minus the old prefix, or the original prefix rather. So this is going to be 4 as well. And the number of host bits will also be 4 because we have 4 digits left for the host IDs. Now, coming to the next part, it's asking us the network address of our IP. This is the IP address we've been given, and it's basically, the question basically means that what network does this particular IP fall into if you're using the /28 prefix. So for this, a simple way to do it is if you head back over to the calculation sheet, we already have in the last octet for the subnet mask, which is 240, so this octet. And now we're gonna make the decimal number 133 into binary as well, and we're using AND addition. So it's called AND addition, where we use AND addition with this mask, this binary number, and 133 converted to binary. We don't need to use 192.168.1 because all of these digits are already 111s. So this will be the same. So then the first part will be the same. We're just calculating which network address or which subnet does this 133 fall into. So for that, the first thing we'll do is we'll convert the number 133 into binary. So we're starting with 128, which will be a 1. Now we keep subtracting. So 133 minus 128, that's 5. So 64 will be 0. 64 will be 0. 32 will be 0. 16 will be 0. 8 will be 0. Now we have 5 left, so 4 is going to be 1. 2 will be 0, and 1 will be 1. So this is our binary number for 133. Now we're going to use AND addition for 240 and 133. So if both, the rule here is if both the bits are 1, then our result will be 1. And if either one is 0, then the result will be 0. And if both are 0, the result will also be 0. So both need to be 1 to make the result, the final bit in 1. So here we have all zeros other than the first one, which means our number here is going to be 128 because only this one's 1, rest all are 0, so just 128. This means that our network address for this particular IP is 192.168.1.128. So this is the network address for this subnet. Now, the first IP on our subnet will be 128 plus 1, so 192.168.1.129. And the last IP will be 1 minus the broadcast. So here we're going to use a magic number trick now. Hey guys, so in the coming clip, I've corrected a mistake that I make later on in the video. So please watch that before continuing in the video. Thanks. Alright, so hey guys, this is the future me. I just realized while editing this video that I actually explained the number of magic, the concept of the magic number in a wrong manner. So what I mentioned here was since we're borrowing in 4 bits, our magic number would be 2 to the power 4, which becomes 16. This is incorrect. I realized this later on when I was actually recording, doing this part of the video. So the concept of magic number in simple terms is that if you're borrowing in 4 bits in here, if you're borrowing in 4 bits on any octet, let's just clear this off. So if you're borrowing 4 bits, we type in 4 ones here in the binary to decimal table or whatever you want to call it. And the magic number basically becomes the last digit of 1 here. So if our 1 here is ending on 16, then our magic number becomes 16. If our 1 would end here on 8, our magic number would have been 8. But if our 1 would have ended here on 128, then our magic number becomes 128. So it depends on which number or how many bits you're taking, and you put those bits in the magic number of table when you're converting, and wherever the ones stop, basically the last one becomes your magic number. So this is how you do the magic number. Please, my apologies for the concept I explained in here that is incorrect. So yeah, hope this helps, and yeah, back to the video. So we have 4 ones here, which means that our magic number will be 2 to the power 4, which is 16. Now this 16 means that each subnet increases by 16. So for example, if our first subnet was 192.168.1.0, our second subnet will start from 192.168.1.16, and this one will end at 192.168.1.15. Now this 15 will be the broadcast address. So for our particular subnet, 128 plus 16 is 138, 144, and minus 1 for the broadcast, because 144 is going to be the next subnet. So for the broadcast, we subtracted by 1, so that's going to be 192.168.1.143. And the last IP will be, again, -1 from the broadcast. So 192.168.1.142. Hope this is clear, because once we have this one, we're going to move on to a much more difficult problem. So yeah, if you have any questions, just let me know in the comments down below, and let's move on to the next problem now. Here we have a /8 prefix, and we're changing this to a /17 prefix. So now this IP was in the class C. Now we're moving on to a class A IP with the class A subnet as well. So our default subnet is 255.0.0.0. And converting this into a sevens will be all ones for the first one, all ones for the second one. Is that 8? Yep. Now, so we have 16 bits. Now just add one more to make it 17. Rest all will be 0. So zeros, and then the last one will be all zeros as well. So this is our new subnet mask in binary. Now, if you move on to the calculation part to find in what this is in decimal. So the last one, 0, we know. And actually, we don't need to use the calculation part. This one's pretty straightforward. So all ones means 255, because that's what the binary results in. And then this one is just, the first one is 128, the rest all are 0. So this one becomes 128, followed by a .0. So yeah, that's our new mask in decimal. Now the number of hosts here will be, we have 800, followed by 700. So that is total 15 0 bits. That means 2 to the power 15 minus 2. This, I think, for this, we can use our table here again. So I have a table. Let's just fill this in. So 2 to the power 1 is 2, 2 to the power 2 is 4, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, and then 16384, and the last one 32768, I think. Yeah, 768. Yeah, so we don't need to fill anything after this. This will be sufficient for our calculations. So if you go back here, 2 to the power 15 is 32,768 minus 2, which will be 32,766. Now, the number of subnets made will be, we started off with 8 and we moved on to 17. So the number of bits we added were 9. So 2 to the power 9, which is, if you go back to our table, 5 and 2. Let's add that there as well, 5 and 2 for the number of subnets made. Now, the number of subnet bits will be 9. The number of host bits we calculated previously were 15. And yeah, now moving on to the AND addition once more. The network address of our IP here. Now, since this is, it's not starting off with a 255 prefix, we have to consider the other numbers as well. So the first two are all ones, which means it's 255. That means that 10 and 1 will be the same. So we can, the first two digits are clear basically. After that, we have the last one's all 0. So our 2 here is going to be 0. And we have to consider the number 130 now. So if we add 130 to our table again, let's calculate this. The first one will be 1, and then all zeros all the way till 2. This will be 1, and the last one will be a 0 again. So we have this, and we have our subnet mask here. So as you can see, the only ones matching here is the first one again. So just ones and then followed by all zeros. Okay, now if we head back over here, we can type in our network address for this IP, which is going to be 10.1.128.0. Okay, so the first IP on our subnet will be 10.1.128.1, and the last IP here will be 10.1.128. This will be 255.254. I'll show you how we got here. And the broadcast is going to be 10.1.255.255. Okay. So now, since we are we're subnetting in the second and third octet, basically, the rules are same, but the way we subnet is kind of different to the ones in the first one. So the first ones we use the class C subnet, we use a magic number trick. We'll use the same magic number trick, but just in a different manner. So here, what we did was we took the number of bits that we added. So we added 4 bits. So our magic number became 16, which meant that our subnets increased by 16 every round. In this one, so we started off with a /8 prefix, and we went on to the /17 prefix. So now this one, the second octet, all zeros were converted to ones. And in the third octet, just one number was converted. So only the first one was converted from a 0 to 1. So our magic number is 128. So we move in iterations of 128, but we also have to consider this particular octet, because technically this was changed as well. So if you're starting off with 10.1. Let's start with 10.0 since it was a /8 prefix. So if you're starting with 10.0.0.0, our first iteration will be 10.0.128.0. So our first number our magic number comes in first, which is 128. Now the second, this will be 127. Yeah, so that's the range for the first one. The second range will be 10.1.0.0. Sorry, the second one will be 10.0.128.0. That's right. And we move on to 10.0.255.255. So this is a range here. And this one here will be 255 as well, because we're changing the numbers. So this will be the broadcast. This is the network address, the second network address, followed by the broadcast for the second one. Now the third one will be 10. Now we're coming into the 1 because we've done the first magic bit. Now we're coming to 1. So 1, and then we start off with 0 again, .0, and then we move on to 10.1.127.255, and then 10.1. This time we're starting off with 128. Sorry, .0. And we are moving to 10.1.255.255. So our range basically goes in this manner. So it starts off with 128 because this is the third octet. This is the second one. Once you complete the third octet, you move on to the second octet, and then you go back to the third octet. So this is how we use a magic. This is how we use a magic number in if you're subnetting in the second or third octet. So here, the first for our particular network address, which is this one right here, 10.1.128.0, because we use the AND addition in the calculation table here to figure that out. So this one is just 128. The first IP on our subnet will be here because this is the host bits. These all are the host bits. So we're starting off with 128, and then we're adding 1 to the network address. And our last IP on our subnet will be 1 minus the broadcast address. So 255, and then this 255 minus 1, which is 254. And then the broadcast IP will be this one. So this is the first subnet. This will be the second subnet. This will be the third subnet, and this will be the fourth subnet. And then you go onwards to the last one. Yeah, so that was it for these exercises. In the next videos, we'll be going through a different kind of subnetting exercise. And then the third video will be VLSM. So thank you all for watching. If you have any questions, again, please drop down in the comments below. And yeah, see you in the next video.